Hello, everyone. So this is another MATHCOUNTS question. So this was 2022 state team run number 10. So we have equilateral triangles. The side is given. A point inside of the triangle is called special if this is a point that is 3 centimeters from one side and 7 centimeters from the other side. Okay, consider the convex polygon. Those vertices consist of all those special points. What is the area of this polygon? Okay, and then we want to find the area as, okay, nearest 10. Okay, so let's get kind of like start with like drawing the triangle. Since we are told that's equilateral triangle, it's better to start with that. So let's go with that. So we have a equilateral triangle, and I'll try to make it a bit bigger just to kind of see how that will be useful. So okay, so we have, let's say these are ABCs. Since we are given the side length is 8√3, so we can find a lot of stuff from there. But before we get into this, maybe it's better to remind something some people may know as called Viviani theorem. So it's basically whenever you have a triangle, so let's say we have a triangle. It doesn't have to be equilateral triangle, it could be anything. So whenever you have a point inside, let me take, let's say this point. And if you take this point and drop the altitude to each side, let's say these are some altitudes from that point. Okay, so the sum of the altitudes from that given any point inside of that triangle, so let's call this is ABC, is I'm gonna call H1, H2, H3. Some of those three is actually same as the height of the triangle that we are given. Okay, so we can like use this in general like, with the equilateral triangle, but we can extend this in other triangle as well. But since this is a equilateral triangle, we are gonna use just for this for now. Okay, so if you are wondering why that's the case, you can make a like splitting this triangle into three different triangles. So you can find the area of the ABC in two different ways. The first way, you can just say the altitude from A to BC, I'm gonna call that H, and then times BC, okay, over 2. Again, let's assume this is equilateral triangle, okay? And this is equal to area of this triangle, which will be H2 or H1 actually. H1 times AB over 2. And area of this triangle is gonna be H2 times AC over 2. And the area of the third one is just H3 times BC over 2. Since this is equilateral triangle that we start with, so the AB, AC, and BC are equal to each other, so you can replace with those with the same number. So that will give us H times BC over 2 equals H1 plus H2 plus H3. And I can multiply this by BC. Again, BC, AB, and BC are AC are equal to each other, so we can just replace with all BC. And then if you do see, these guys will actually 2's will cancel, and then BC's and BC will cancel. H is just some of those three altitudes. Again, this is called Viviani's theorem, so you can just kind of keep this in mind. But let's take this guy out of the way for now. This was just a reminder. And since we are told, like whenever you have a point, okay, that's called special if that's 3 units from one side and 7 units from the other side. So if you like drop the altitude from the A to the other side, which doesn't matter like what side you use. So this is the 8√3. So the half will be right here. So 4√3, and this is 4√3 when this is the altitude, because this is 60, this is 30. And you can find this height, which is 4√3 times √3, which is just 12. So 4√3 times √3, and that is just 30, 60, 90 triangle, or you can use the Pythagorean. So this is 12. That is something we know, okay? And what I'm gonna just know, like, the 12 is the sum of the three altitudes, which is we just kind of see right here. And then we are told two altitudes from a point is 3 and 7, which means the third one has to be 2. So you can call like H1 is like 3, H2 is 7, and H3 is just 2, because the total will be 12. Okay, so at this point, I'm going to take this guy out of the way. So we got 2 with that. And what I'm going to do, like, I'm going to place this triangle in a Cartesian plane. But you can just place it anywhere as your origin. What at the same time, you need to choose somewhere that will help us a bit better than the other points. So I guess we can take the centroid of this triangle as my origin, because this is a equilateral triangle. The centroid of this triangle will be my center of the triangle, which will actually have us a bit more details. So since we know this is the 12, and the centroid will divide that 12 into 1:2 ratio. So if I take my centroid like somewhere right here, so that has to be 4 units right here and 8 units right there. Okay, and we already know like 3 numbers. You know, one of the heights, let's say you pick a point, for example, somewhere right there. If this is one of my special points, this has to be 2 units away from one side. Let's assume that's BC, or you could have AB, but let me take the BC. The reason why I'm just choosing BC, because, you know, this is 4. If I take a point that is 2 units away from BC, which is going to be just right in the middle of this 4, which is why it's kind of better to use it. So let's go ahead and draw a line. If I do this, you know, any point on this line will have 2 units away from the BC. Okay. Okay, I'll put that way. So, which is why I can say this is 2 and this is 2. So my special point should be on this line. Okay. And you can do the same thing with this way. You can do the same thing with this way. Maybe it's better to do that. You may use like 3s if you want to, but in this case, I just use 2s, like any point on this line or any point on this line. So your special point should be on those red lines, which looks like maybe somewhere right here, somewhere right here. So whenever you know a special point that is 2 units and 3 units away from the 2 different sides, that means the third side should be 2 units away. Or if you know 2 sides are away, 7 and 2 units away, that means the third side should be 3 units away, which means if you know a point that is equal, like has a distance of 3 and 7, that will determine the third immediately 2 centimeters from the third one. So you just need to show the only 2 of them, because there is only one point that will have those like distances from one single point, all 3 sides, because the sum has to 12. Okay, has to be. Anyway, so that is something, you know, at the same time, since we have the larger one equilateral triangle, that means this smaller one inside is also equilateral triangle, because we just draw parallel lines. So this is like 60, this is 60, this is 60, and stuff like that. And if that's the case, you know, the point that we had as centroid, maybe we should label it. This is actually centroid of the smaller triangle as well, which means this is 2. That means this has to be 4. So we can just go with this is 4. And let me see if that's, yeah, that's 4. And then the whole distance was 8. So which is why this is gonna be 4 as well. Okay. And we just like to find a point that is gonna be 7 units away from one of the sides. So it's kind of better to use this BC. If you start from here, okay, so and then if you just go all the way to the like up by 7 units, so this is 4, so you just need to go 3 units away from here. So it will be somewhere right here. So let me have that as well. So I'll try something like this. Maybe a bit higher than that. Okay, so let's try that point. So again, since any point on this line is gonna be 7 units from BC, this was 2, and this is 2, so which means this is gonna be 3, and that will be 1. So this guy right here is just 1 unit. So the point that we are looking for as special is gonna be, this is one of them. This is one of them, because this point has 2 units away from that AC. This point is 7 units from BC, which means this point will be 3 units away from AB. And the same reasoning with this guy. So these are the 2 points that is we can call as special. And if you use a similar reasoning, you know, you are gonna get another 2 point, like if you draw this line, if you draw this line, so you will get another special point right here, another special point right there, another special point right there, special point right there. And the question is asking us to find that region. So maybe it's better to highlight that region a bit colorful way. So we are gonna find area of this region. Okay. So it doesn't look like a really nice view, but actually it is a bit better if you just make it a scale to draw. So what we want to know is the inside of this region, right? So we just need this region. And you may see this was the equilateral triangle. So you can find the area of the equilateral triangle and subtract the smaller ones, right? And then all those small's are equal to each other. So the larger one, we just know, you know, the height was like, this was 1. And this is like 3, this is 2, and this was 2. So if you subtract 1 and 2, which is 3 from 7, I mean, actually, let me see. Yeah, this was like 7 units away BC. So that means this is 5. So if you add 1 right here, this is 6. So this distance is 6. So let me make it that figure. So it's something like this. So this is 6, and then we know this is 60. If you divide 6 by root 3, so you will get 2 root 3, so which is basically this segment. And if you double that by 2, if you double like this number, so you will get 4 root 3. Again, this is just 3690 triangle. So now we have the this side as 4 root 3. So if you know the area formula for equilateral triangle, which is s squared times root 3 over 2, and that's the area of equilateral triangle. I can use this 4 root 3 because this is my 4 root 3. So 4 root 3 times 4 root 3 times root 3 over, so this has to be 4, divided by 4. And then these guys will cancel. So 3 and this will be 3. 4, 3 is 12. So that will be 12 root 3. Again, this is the area of the equilateral triangle right here. Maybe I'll just highlight that part. So the region that I got so far is this part, this equilateral triangle. And then what I'm gonna do, I'm gonna subtract the small one on those 3 corners from 12 root 3 to get what I want. Okay, so since you know this is 1 and the height was 6, which is 1 out of 6, right? So if the so if the ratio is 1 out of 6, okay, so you can compare the areas easily by taking the square of the scale, which is gonna be 1 over 36, which means if the larger area is 12 root 3, the smaller will be 1/36 of this guy. So 12 root 3 times 1 out of 36, that will give us just one of these equilateral triangles. So let's say this region. But we have 3 of those, so we need to multiply this by 3. And we need to subtract this from 12 root 3. And this is gonna be what we really want. So 12 root 3, and that should be 36. 36 will cancel, so minus root 3, which is 11 root 3. And since this is a team run, so you can just plug this in calculator, so you will get approximately 19.1. And that should be my final answer. So just to summarize, so we start with like equilateral triangle, and then we find the third distance from that special point to the missing side. It has to be 2, 3, and 7. And whenever you know 2 of them are like somehow like fun, that means the third should be already determined by those 2 points. So we just need to find those 2 like like distances from a special point. So and then I just start with drawing a parallel line to the base that is 2 units away, which means anything on this line was 2 units away. So which means my special point on has to be on this line. And also, if I just draw another line that is 7 units away from this line, which will be, you know, like this guy. So these were also 2 units away. And then this line is gonna be another like line that we already know that is gonna be having all the points that is 7 units away from this. So which means any point on this line, any point on this line, and this line will be my special point, which is why we got those 2 points. And the same reason we got these 2. So whenever we have the area of this triangle, let's subtract those 3 corners, and that is actually what we got. So maybe it's better to shade those the same color. And we just use some similarity to get some ratios. So that was the answer. I hope that was clear, and I'll see you in the next video.